Okay, today we're going to take a look at relational databases and SQL. This is by way of introduction, so if you haven't come across these concepts before, by the end of this session you should know enough to be able to make some good progress on your own. So the first thing we need to think about is the data and relationships between the data. Often data will have relationships between different sets of data. For example, a club will have a manager. A player will play for a club, and a club has many players. So we've got information about a club, maybe its name, address, that sort of thing. We'll have information about a manager, his or her name and address and telephone number and so on. And we want to form a relationship between those two entities, the club entity and the player entity. Now, if we're writing this to file, then we would need to write that data to the file. We've got these two objects in our object-oriented program where we've got a club and a manager, and the club has got a reference to manager and manager has got a reference to club. But when we write this information to file, to a text file for example, then we would represent those relationships by using the identifier. So the club, when written to the text file, will have the manager's ID as part of the club's record, and the manager, when written to the text file, will have the club's ID as part of the manager's information. But when we're using files in this way, it can be a bit difficult or indeed inefficient to try to retrieve that kind of information from separate files, or even from the same file with lots of different records. And this is where we can make use of relational databases, because as the name suggests, we can hold data in these databases and we can relate one piece of data to another. And we'll do that by holding information about similar entities in a table. So we can see on screen here we have a definition of a club entity which contains a club ID and a club name as the attributes for that data. And in another table we've got a manager entity with a manager ID, a manager name and a club ID. But that's only the definition. At some point we need to start storing data, and that data will be stored in these tables. So there will be a table for club and a table for manager. Each row in the table will represent one entity. So we've got club number 1 with a name A team, club number 2 with a name R team, club number 3 B team. So each row is a separate entity within that table. Similarly for the manager table, so we've got manager ID, manager name and club ID as the column titles, and then each row represents an individual entity within that table. Just to see how these relationships work, you tell me who the manager is for the A team.
Phil.
Phil. How do you know?
Because it has the club ID 1.
Because when you look for A team, we find out the club ID is 1, and then we look down the list of managers looking for which manager has got the club ID 1. That's it. That is relational data. Now, of course, we could make it a little more complicated, and we will do, but that fundamentally is what it's all about. What we can do then is to identify these relationships diagrammatically in the entity relationship diagram. These entities, they become the tables in the database, and the line between them represents a relationship of some form. In this case, what it's telling us is that a club has a manager, and the symbols at each end of the line tell us, in this case, that a club, look to the manager side of the line to see the multiplicity. So a club has got 0 or 1 manager. And then if we stand on the manager side of things and look back down the line, we can see the club multiplicity. So a manager has got 1 or 0 clubs. And so that's indicating to us that a club can exist with or without a manager recorded, and if there is a manager, there is only one manager. A club cannot have more than one manager at a time. Now this is called the crow's foot notation for reasons that are not yet obvious, but you'll see in a moment why. we have the entity name, which will become the table name, in the top part of that entity on the diagram. We then have attributes. There are two attributes, one of which is called club name. That will become a column name in the table. The club ID is used to identify each club, and therefore that identifier must be unique in that table. So you cannot have two clubs with the same identifier, because then we wouldn't know which club you meant. If we said, oh, go to club 1, and we find two clubs with the ID of 1. Now, because this is unique, we call this a primary key, hence the little PK notation. And that just signifies that this attribute is used as the unique identifier for each entity in that table. In the manager entity, there's the FK notation, which means foreign key. And this indicates an attribute that will hold an identifier from a related table. Now we can tell from the name of the attribute, club ID, that this is going to hold the ID for an entity in the club table. When we saw that table earlier on and we were able to work out that Phil was the manager for the A team, that was because we could see in the club ID there was a value 1, which is the foreign key that relates to the corresponding primary key in the club table. And then we have the line, which is the relationship that draws attention to that relationship that has been formed by the foreign key in the manager table. Okay, so remember, each row in the table will represent one entity. So in the club table, we've got 3 entities. In the manager table, we've got 3 entities. The primary key value of the related row is shown in there and links us to the corresponding entity in the club table. And likewise for Jan, who now manages our team. So here we get the reason for the term crow's foot notation. There are different kinds of notations for entity relationship diagrams. What we're going to use on this module is Microsoft Visio with the crow's foot notation. And the crow's foot is apparent when you have a one-to-many relationship, which is what's currently displayed on screen. So now what we've got is a club has, now we look down that relationship line, 0 or many players. That relationship then is implemented in the attributes on the player table, where you can see the club ID as a foreign key for player. Now what this means is that when we create the database tables and we put data into those tables, in other words, we populate the tables, then there will be multiple player entities that have got the same club ID. And that's what you would expect. If you've got a football team and you've got 20 people in your squad, then there will be 20 separate rows in the player table, all with the same club ID. And so we've got an example here where the 2 rows in player table with player ID 3 and 4, that's Rosie and Jim, have got the same club ID, and they both play, therefore, for the A team. So here we get a little more complication now, because we've got 3 tables, and we want a bit of information that comes from 2 of the tables that are not directly related. So we want to know who is Rosie's manager. From the diagram, we can see that Rosie is a player, and that the player has a relationship with club. We also can tell from the diagram that the manager has got a relationship with club. So club is the common table between these 2 other tables. And so what we'll need to do is to work out which club does Rosie play for, and from that bit of information we can then find out who Rosie's manager is. Rosie has club ID 1, therefore by going to the manager table we can find that Phil has got the same club ID as Rosie has got. For us to manipulate these tables within a relational database, we use a structured query language, SQL, sometimes called SQL. SQL can be used to do all kinds of things in our tables. We can create and delete tables, we can insert new rows, update existing rows, delete rows, we can retrieve data, and that's called querying a table. What I'm going to do now is just run through some of these commands, and the create table command in SQL is create table. The case doesn't matter. I've written it in uppercase just to show you what is part of the SQL notation. If we're going to create a table and we want that to be the club table, then we would create table club, open bracket, and then we list all the columns along with their data types and any constraints. So you can see in the lower half of the screen here that we've got club ID as the first column, of type number, and the constraint is primary key. So that immediately enforces the constraint that the value in club ID must be unique within the table. Then a comma, and then the next column, which in this case is club name. Varchar is the type, 20 is the length. Now I'm using here SQL syntax for the Java DB or the Derby database. If you're using Oracle, for example, then the data type would be varchar2 and then in brackets length 20. So that's the data type and its length, and then a constraint, not null. That means that club name is not permitted to be empty. You have to provide a value for every row in the club table, and it must be unique. So we're saying that we cannot have duplicate club names. If we want to delete a table, we must use the drop table command. There is a distinction between drop and delete. Drop means to remove the table from the database, whereas if we were deleting, as we'll see in a few minutes, we don't actually remove the table, we're just taking rows out of the table. So to completely remove the table from the database, we use drop table, followed by the name of the table, so drop table club. To insert a row, we provide the table name and optionally some column names, followed by a list of values. Now, if we don't provide the column names, we must make sure that we provide a value for every single column in the order in which they exist in the database. On the other hand, if we don't want to use all the columns, or we want to provide the values in a different order from the way in which they were created, then we would do as shown here. The second example here, insert into player, open brackets, then the column names that we're going to provide values for, which is a comma separated list of column names, close bracket, and then values, open bracket, all the values that we've said that we're going to provide for those columns. And we must list those values in the same order in which we have listed them on that previous line. So because we've said we're going to insert into player, player ID and then player name, then values must have first the ID value and then the name value. Notice that for strings we're using single quotes. When we want to update rows within a table, what we're doing is changing. So we're not inserting, we're not creating new rows, we are changing existing rows. And the syntax then is to, first of all, to have update and then the table name, followed by set and then one or more column name equals value pairs. We can change more than one column at a time. And if we were to do that, we'd have column name 1 equals value 1, comma, column name 2 equals value 2, and so on. If we don't have what's called the where clause, then it will change every single row in that table. So if we want to limit the changes to just specific rows, then we must specify a where clause that has a condition to identify which rows we want to change. So in the first example, we're going to update club and set the club name equal to top team, but only where club ID equals 1. If we forget to put that where clause, then we're going to attempt to change every single club name to top team. Now that won't work because, if you remember on that previous screen when we were creating the table, we said that the club name had to be unique. so that would fail. But if we didn't have the unique constraint, that would change the club name for every single row in the table. So we don't want that. We're just going to say only where club ID is 1 are we going to make this update. Second example, update player, and we're going to set the player name equal to James, where player name is currently equal to Jim. And now that will change every single row in player where the player name is Jim. So it's possible that we could have multiple players with the name Jim. They would all have their name changed to James. If we want to delete a row or multiple rows, then we use the delete from command. This is different from drop table. Drop table physically removes the table from the database. Delete does not. Now, if we were just to put delete from club, and that's the end of the statement, then that would delete every single row from the club table. Now, if that's what we intend, that's fine. What that will leave us with is the club table still in the database, but it will have no data in there. To prevent that, if that's what we want to avoid, then we must specify a where clause. So we're now going to, in this first example, delete from club, where the club name is equal to top team. So only that or those rows that match that where condition will now be deleted. We can delete from player where club ID equals 1. Now if we've got 12 or 20 players, each with club ID equal to 1, that statement will delete all 20 records from the player table. Delete from manager is going to delete every single row from the manager table. So we really need to be careful about the delete statement, because if we don't specify a where, it's going to delete all the rows. When we want to query a table, we use a select statement. Now, querying is where we extract data so that we can then display it or make use of it in some way. Now, the select statement has the following format. We select, then we have a list of column names, which are comma separated, from, then a table name, then we can specify a condition if we want to, and also an order. Let's see some examples. Select star from club will select every single column from club, and because there is no where clause, it's going to select every single row. So this will give us all columns and all rows that are in the club table. The next example, select player ID, player name. Well, that's only going to select 2 columns, and it's going to select those from player. Now, obviously, we've got to make sure that we spell those column names correctly, otherwise there's going to be some kind of error when this tries to execute. Select player ID, comma, player name from player, and now we're saying we want to do that where club ID equals 1. So that will now only select those players whose club ID has got the value 1. And in this example, we're also making an order by clause. So it's going to order by player name. Now that means that those 20 rows that were extracted through that where clause will now be sorted into ascending order of player name and will be presented in that sorted order. If you want it descending, then it will be order by player name descending, or the shortcut for that, DESC. And then that will give it to you in descending order of player name. So let's complicate it a bit further. We want to select data from 2 tables. So we're going to select column names from the 2 tables with join in between. So we're going to select from table name 1, join table name 2. In other words, it's going to stick together the rows from these 2 tables. And it's going to do that based on this condition. Let's take a look at the example. We're going to select the table columns, so club.clubid, club name and player name. We don't need to put club dot in front of club name, because there is only in those 2 tables 1 column called club name. Likewise, we don't need player dot in front of player name, because there is only 1 column amongst those 2 tables called player name. But both tables, both club and player, have got a column called club ID. And therefore we need to say which one of those 2 we want to extract. They're going to have the same value, so it doesn't really matter which one we go for, but I've decided to go for the club table, so club.clubid, and that disambiguates the column. So we're selecting those three columns from club, join, player. So we're going to stick together the rows from those two tables, but we're going to do it based on this condition: club join player on club.clubid equal to player.clubid. So what this will automatically do is what you did earlier on when you were presented with the two tables, and I asked you who is the manager for club number one, and you worked that out by following that relationship and saying, right, well, which manager has got a club ID that matches the club that I'm looking for? That's exactly what this statement's going to do with club and player. It's going to take the club number one, and look for all the players that have got club number one, and it will find that first one and stick it into one result set table row. So what we get out of a select statement is called a result set. So the first player, let's say the first player has got club ID 1, will be stuck together with the row from club table whose club ID is 1. So we'll end up with a club ID 1, club name A team, player name, whichever that first player was, Rosie, I think. Then there's another player that has got an ID equal to club 1. So that would also be extracted, club 1, club name A team, player name Jim. So that now gives us two rows. Then there's going to be a second club that has got, I don't think we had any players, so we'll just get nothing for that because there was no player that matched, so we don't get anything come out. Then there's the third club which had one player, so that club details in that row will be stuck together with the player details in the corresponding player row, and that becomes the third row in our result set. And so what we end up with is a result set that contains those three rows containing the matching club and player values. If you want to query three tables, well, we use join again. So what we do is we join two tables, and then having joined those two tables, we join a third one onto those two that have previously been joined. So we select the column names we want from table name 1, join table name 2 on some condition. So that gives us the first join. That produces two joined tables. And then to that result set, we join table name 3 on, and then the condition for that join as well. And we can just keep adding join after join after join, depending on how many tables we want to stick together in this query. Again, we can specify a where condition. So we might say, I want to join club join player on club.clubid equal to player.clubid. Then another join. So we've got club and player joined. Now we throw into the mix another table, join manager on club ID in the club table equal to club ID in the manager table. And so what we'll end up with is data from three tables all stuck together in one row of the result set. So we'll have, let's say, club 1, player 1, manager 1. Then the next row in the result set, club 1, player 2, manager 1. And then the third row could be club 3, player 4, manager 3, and so on. Now when we're creating a table, we might want to have an automatically generated primary key. The syntax that's showing now is correct for JavaDB. You have a different mechanism if you're using an Oracle database. What we've got here, as well as club ID number primary key, which is what we had on the previous example, we now have generated always as identity, open bracket, start with 1, increment by 1, close bracket. What that will do for us then is every time we insert a row into the club table, we no longer have to provide the club ID, because that will automatically be generated. So, the first row will have the value 1, the second row will have the value 2 because we're going to increment by 1 each time.
Can you not use command, is it auto increment?
The one thing to watch out for is that different database management systems are going to have slightly different syntax for this kind of operation. So that in general, the syntax that I've shown you so far for SQL is pretty well standard across those various database management systems. But things like the auto increment, that's a bit different depending on which database management system that you've got. Now, if we want to put in a foreign key, and we do, then we can add these constraints in this way. So we've got the player table. You can see now that the player ID is going to be automatically incremented, starting at 1, incrementing by 1. Player name set up as before, club ID set up as before. It's an integer because we know that in the club table that was set up as an integer, which is auto incremented. So now we want to make the club ID in the player table a foreign key that links to the club ID in the club table. And we do that by using this other constraint here, foreign key. What we have in the brackets is the column name in this table that is going to be the foreign key. And we then link it by using references and then the table name, club, followed by the column name in club. So what we've done then is said that the club ID in this table is now a foreign key that references the club ID in the club table. Once you've done that, you can be satisfied that your database management system will now enforce these foreign keys, which means that if you've got clubs 1, 2 and 3 and you try to insert a player whose club ID is 12, then the database management system, because of this constraint that we've now put in, will say, no, can't do that. There isn't a club whose ID is 12. If you don't put the constraint that is highlighted here in bold type, then you could indeed insert a player into the table with club ID equal to 12, even though the club ID does not exist in the club table. So it's not enough just to have the club ID column in the table. To make it really secure, you then need to put in that foreign key constraint. So how about we do this in Java DB? Well, we can do that through NetBeans, which is very straightforward to do. There is, with the Java Developer Kit, the Java DB as well, and we can access that through the Services panel in NetBeans. So if we pop into NetBeans here, you're familiar with the Projects panel. You've also got the Services panel, which if it doesn't display, you can access through the Window menu. You've got here the databases. If you expand databases, you'll see that there is a Java DB and a sample database. So to create your own database within Java DB, right-click on Java DB and create database. Then you put in your own database. I'm going to call this test. That's the database name. You create your own username and password. So please make a note of these because you will need them later on. I'm, just for the sake of things, keep them simple so I can remember them. Test, test and test. Of course, you would want to use something much more secure than that. Then click OK, and it's going to create the database. You can see down here that the output panel is opened, showing us the Java DB database process, and it's just going through the motions to say what it's doing. And when it has done what we've asked it to do, we'll see up here that the database has now been created. And if we connect to that, you'll see that the icon has changed from a broken symbol to a complete symbol, so we can now expand that. There's our schema, which has got our username, and then within that, tables, and we've got no tables. If you were to open up the sample database, you would see in tables all of those tables there, and you can explore those if you want. We can execute commands to query, insert, delete, update, drop, and so on. We can do all of those from a panel. I'll show you just now how we could do that. In our test database, I'm going to right-click on table and select execute command, which then gives me this editor panel. Well, why don't we copy and paste? So having copied and pasted this, the very first time that I execute this, I'm going to get 2 errors because there are no tables to drop. So I'm actually going to cut those out. Now if I execute this, just by clicking that run symbol there, it's told me that execution has finished, no errors, And you can see over here that club and player have now appeared. If I reinstate those two drop commands, that will now delete those two tables and then recreate them when I execute. So again, no errors. So if, for example, as part of your testing, you make a mess of the data that's in there and you want to reinstate it, then you can do this. You can drop, create, and you've got some blank tables. What we could also do is copy and paste those insert statements. So now when I run this, not only will it drop the tables, recreate them, it will now insert these items or these entities as rows in the table. Again, no errors. Now, how do I know that that's happened? Well, I want to view the data, for example. So I could right-click and view data. So that will execute that select statement and show me the result. So we've got here the club ID 1, club name A team, club ID 2, and so on. If I wanted to, I could have typed this manually and then execute, and now it shows me the player table. So that's shown you the basics of SQL, the concept of relational databases that have got tables that are related in some way. Those relationships need to be enforced by the database management system. So when we use the SQL to create the tables, we put in those foreign key constraints. We need to populate those tables, so we use insert statements to do that. And then we can use select statements to query the tables to extract data. So you can go and practice by using some of those examples. Just copy the examples, paste them into the NetBeans editor panel there, and run them and see what you get. Then you can play around with the queries. You can't really do much damage. You might corrupt your database, in which case just recreate them in the way that I showed you just now. So have fun with relational databases. In our next session, we're going to look at how to use a relational database from a Java program.